Okay, we want to find the antiderivative of this function. So we have the function to be 2x plus 1 divided by x squared minus 7x plus 10. Alright, great. And now, when we have a stuff like this, where the denominator is factorable, alright, we can easily use partial fraction decomposition to get this to be a lot more easier. Alright, so let me start off by using partial fraction decomposition of this integrand. So I would like to put the integrand out as 2x plus 1 divided by, well, this denominator, let me just get the factors of the denominator real quick. So as you can see, this is a quadratic term and it is factorable, and the factors are x minus 2 times and x minus 5, x minus 2 and x minus 5, right? Those are the two linear factors that would make up that quadratic term at the bottom. So as you can see, if you multiply this out, if you multiply this out, we're going to get back the original in the denominator. Okay, great. So when we have these factors in the denominator, we usually decompose them into two, because we have two factors right there, into two partial fractions, all right? And then the first bracket, the first fraction, I'm going to put x minus 2 to be its denominator, and then the second fraction, I'm going to use x minus 5 as its denominator. All right, so the next thing we have to do is to factor out what the numerators will be. And in this case, since we just have linear factors in the denominator, we're going to have constants as the values we need to find. All right, great. So I'm going to do this real quick. Now, to find the numerator for this first fraction, I'm going to substitute x equal to 2 into this main fraction, all right? When we do that, the result we get will give us what we have here. That's just what we call the cover-up method. All right, so when x is equal to 2, you notice that this denominator will be 0. I cover this x minus 2 up, okay, the same factor here, I cover it up, and I substitute 2 into the other terms, all right, where I find x. So we're going to have 2 times 2, which is going to be 4, plus 1, that is going to be 5 at the top. And then we divide that by, when we substitute 2 here, that's going to be negative 3 at the bottom. So we're going to have negative 3. Take note, you're going to cover this up. You're not going to substitute into the term. So that means the first number we are looking for here is going to be negative 5 over 3. All right, so to find out what the numerator will be over here, we check when x is equals to 5, right? We substitute that here, covering this x minus 5 up. So that's going to give us 2 times 5, which is just 10, plus 1, that is 11, divided by 5 minus 2, which is just 3. So this second numerator will be just 11 over 3. And as you can see, it is positive, so I can put the positive sign over here. All right, great. And maybe let's rewrite our integrand with its decomposed stuff. We write the integrand as, I'm going to put down this, all right? So we can rewrite it as, let's say, 11 over 3 times x minus 5, right? Then minus 5 over 3 times, let's say, x minus 2. And then we are doing that over the x variable. Okay, very nice. So as you can see, that's exactly what I put down there. And now you can see we can take out 1 over 3, right? And when we factor out 1 over 3, or maybe if we like, we can split the integral, okay? Because the integral of the difference is the difference of the integrals. We're going to have 11 over 3, right, times the integral of 1 over x minus 5 dx. And then we subtract the integral of this from that. That's going to be the integral, or let me put the factors, the constants out front. So we're going to have that 1 over x minus 2, and then you put down over the x variable. All right, great. And now let's see what we've got. This is going to be, well, 11 over 3. Let's see. All right, now the integral of 1 over x minus 5. Well, if we take the derivative of x minus 5, it's going to give us 1, okay? That tells us that this integral will just give us times the ln of x minus 5. And you know that the logarithmic function is only, the logarithmic function exists for positive numbers only. So this is going to become minus 5 over 3 times the logarithm of x minus 2. All right, and then we add an arbitrary constant to that. And this right here is the antiderivative of the function we were given earlier. All right, thanks for watching. Please subscribe to my channel.